For those of you who are coming into mechatronics having never seen, or at the very least never used, a solderless breadboard, this tutorial is just a quickie to get you up to speed. A solderless breadboard is a wonderful prototyping tool because all you need to do is plug the legs of the jumpers and the parts that you're connecting into the right holes, and magically you have a circuit. I happen to have the permanent version of the solderless breadboard for demonstration. So as you can see, it has holes that are roughly aligned. So as you can see, it has holes in roughly the same pattern as the solderless breadboard, except for it's on a printed circuit board with metal pads. If you look on the back of this, you can see how they're interconnected. Most of the holes, the ones that are in these two groupings here, are connected in groups of 5. So if you plug something into this hole, for example, and then something into any of the other 4 holes, they'll be electrically connected, just as if you connected them with wires or solder or twisted them together. But none of these holes are connected to any of these 5. And none of these holes are connected to any of these 5, and none of those holes are connected to any of the top and bottom 4 rails. The top and bottom 4 rails are usually used for power transmission, because most of your components, especially on a more complicated circuit, are going to be connected to your power supply at many points. And to simplify that, if you plug in your power supply to one of these holes, all of the holes all the way along become part of the positive supply. So it's very easy to just connect the power supply to 2 of these rails. And so it's very efficient to just connect the power supply to a couple of these rails and then have all of your circuits dropping from the rail that has the power supply to the middle sections where the circuit is, and then to the negative supply on the bottom rail. For this tutorial, I'm going to make a fairly simple circuit that has 3 LEDs and 2 resistors. And we're going to draw the schematic with the understanding that it's going to go on the breadboard. So the first thing I'm going to do is decide that I'm going to use a 16 volt power supply. And I'm using 16 volts because in the assignment, I happen to know that the peak voltage of the AC supply is 16 volt. So we're going to have the DC supply for the purposes of this tutorial. With the positive of the supply going to a point on the top rail, and the negative of the supply going to a point on a bottom rail. From there, we're going to put a resistor, a current limiting resistor, feeding a red LED and a green LED on the board. To do that, I'm going to take a resistor and go from the top rail to one of these groupings of 5. I'm going to take the LED and also plug it into the same grouping of 5 that the resistor is part of, to the lower group of 5. And we want the red LED to turn on when the upper rail is positive, so it'll be oriented this direction. Then to get back to the power supply, we're going to go from one of the holes that the LED is plugged into to the bottom rail with a jumper. And that will complete the first subcircuit. The second circuit is going to be the green LED, and I'm going to insert it so that it actually is reverse biased, which means initially it's not going to turn on. For the green LED, we're going to do this slightly differently. We're going to take advantage of the current limiting resistor and the fact that the green LED is going to be oriented backwards, reverse biased, so that we can actually share the resistor because only one LED will ever actually be on at the same time. So we're going to go from the common connection point between the resistor and the first LED, and we're just going to go over to another group of 5 beside it. Then the green LED is going to be reverse biased. And the green LED, I'm going to actually jump all the way down to the negative supply rail, bypassing this group of 5, because we don't actually need a jumper, the legs are long enough. So here's the second subcircuit. And for the third circuit, I'm going to use a special LED, which is called a bicolor LED. And although it looks like a normal LED with 2 legs and a plastic housing, inside this LED is actually 2 LEDs oriented just the same way as we've done with these 2 on the breadboard. So again, we're going to come from the positive supply rail. Just for fun, we're going to go at a diagonal, because sometimes you need to do that. We're going to put the LED going from that group of 5 to the bottom group of 5. Red LEDs have a forward voltage drop of about 2 volts. Green LEDs have a voltage drop of about 3 volts. And the RG, the red-green bicolor LED, has a voltage drop of 2 volts or 3 volts, depending on what direction the current is flowing through it and which LED is lighting up at the time. So we're going to design around the worst case, which is all of the LEDs being 2 volts, to determine what resistor value we're going to use, and we'll just use one resistor value for both places. The power supply is 16 volts. The voltage drop of the LED is 2 volts, which means 14 volts is going to be seen across each of these 2 resistors. For 14 volts, if we want a maximum of 20 milliamps to go through each of these branches, we need a 700 ohm resistor. 700 ohms is not a standard resistor value. You can get any resistor value that you want if you're willing to pay a little bit of money and wait for the delivery. In our case, we're going very simple, and we're just going to increase the resistor to a standard value. I'm going to use 1K resistors, 1000 ohms, which are extremely common, and we're going to recalculate the load current based on using a 1K ohm resistor instead of a 700. So it's still going to be 14 volts across the resistor, but now we're dividing it by 1000 ohms, which is going to give us 14 milliamps. So now let's build the circuit. So we know we're going to plug the power supply into the top and bottom rail at the first hole. So the first resistor, so we'll put the first resistor from the top rail to a group of 5. Sometimes it takes a little bit of a wiggle to get the legs in, but we will take the red LED and put its long leg in the same group of 5, and the short leg in the bottom group of 5. And then we'll complete the circuit by sticking a jumper in the bottom group of 5 going to the bottom rail where the negative power supply is connected. The green LED is going to go in with the long leg on the bottom set of 5 and the short leg on the top set of 5. With a jumper going from the resistor and LED to the LED. And from the green LED down to the bottom rail. I was going to just put the green leg into the bottom rail, but this LED's legs are a little short, so although we could do that, we're going with a jumper. And finally, for the bicolor LED, we'll go from the top rail to a somewhat distant group of 5, and the bicolor LED, which, because it does have quite long legs, I'm going to use it to go all the way down to the bottom rail in one shot with no jumper. So now if we connect the power supply, and turn on the power supply, you'll see that the red LED is on because it's forward biased, the green LED is not on because it's reverse biased, and the bicolor LED that has a red and green in the same package is currently forward biased on its red component and reverse biased for the green component, so we get a red LED. And the power supply is showing 28 milliamps, which is exactly in line with our calculations, because this is drawing 14 milliamps and this is drawing 14 milliamps for a total of 28 milliamps at 16 volts. If we now reverse the power supply, so that instead of having the positive going to the top rail, we have the negative on the top rail and the positive on the bottom rail, now the red LED is the one that's reverse biased, and the green LEDs in each of those is forward biased. In this case we have 27 milliamps, showing that the voltage drops between the red and the green are slightly different. And finally, just for fun, I'm going to connect, instead of a DC supply, which is a stable, unchanging voltage once you set it, we're going to connect a function generator, which for all intents and purposes is a fancy power supply that can give us patterns of voltages. So currently I have the function generator set to approximately 0.5 Hertz, which is 1 cycle every 2 seconds. And it's putting a sine wave, so we have a gradually changing voltage. In the case of the power supply, we set 16 volts. In the case of the function generator, it tops out at plus and minus 10 volts. So you'll notice that the LEDs are also a little bit dim. If I change the function generator to output a square wave instead of a sine wave, the LEDs don't fade from red to green. They snap from red to green, because instead of having the voltage smoothly transitioning through a sine wave from positive 10 volts to negative 10 volts, it's now snapping straight from positive 10 to negative 10 and back. And with a function generator, we can also change the frequency. So we can very easily ramp this up to a point where your eyes can't tell that it's blinking anymore. And the LEDs look continuously on. And if you look closely, you'll see that this LED has two very distinct red and green elements to it. And finally, Because this is a solderless breadboard and inherently temporary, the last step is you can either transfer your components to the permanent board and make something that you can keep forever, or you can turn off the power supply so that you don't short circuit anything and gleefully rip things apart to be reused in your next circuit.